Okay, this is Karen O'Brien, and what we are going to do today is to set up how to review the channel for this Module 10 that we set up over the past 2 weeks. So let me show you. The final step was to export the data, set up the control parameters, export the data, and then run the model. And what that gave us was Lesson 2 export with the .dat files and the .out files. So today we're going to go over these files shortly, briefly, and kind of show you what they are. Hopefully this won't take the whole hour. So I have chan or chan.dat, chanbank.dat, highstruct.dat, inflow.dat, outflow.dat, and exec.dat. Those are our dat files that we made. I'm going to open these up in Notepad, but I'm going to close a little bit of stuff that we don't need. So let's just start with the simple stuff. The inflow, well, the outflow file's simple. Oh, there's a problem here. This is actually not supposed to be in here. That's from an older, some stuff I was doing today. So when we exported this after we were finished with our run, our outflow.dat should have just a K line for the channel and an O line for the floodplain. That's all it needs to get the boundary conditions set up for this channel. And again, so when the water comes down here, it's going to hit this cross section and leave the sink out of the system at normal depth discharge. So that's your outflow condition. Very simple for this case. Inflow.dat, we added another line. So now instead of an F line that was for our Grover in, we also have a C line. So I'm going to Control F and just put in the letter C, and that will take me down here to my first channel inflow node, and I only have one that is assigned to grid element 53420, and it has a hydrograph data time and discharge that goes into that cell over a 24-hour period. And that is this guy right here, right here. And if you went to the boundary condition and you went to your greenway in, you would see that you could get your thing. Let me try to turn on the flow duty plot panel, and let me try to dock it back down here with this guy. Ooh, it doesn't want to dock. That's too bad. Well, let me just do this so you can see. I was messing around with it today, so you can see that it looks pretty good. And that is the inflow hydrograph we introduced into the first channel cell. So again, when this discharge gets added to the model, it gets added to this cross section and then starts to move downstream. No, you didn't join halfway. Don't worry, Creighton. You're good. You just missed a couple of minutes. Don't worry. I got you guys on. I've got the questions on so you guys can ask questions as we go. All right, then we put in our hydraulic structures. So let me get back here. So again, I'll close the inflow.dat. We're done with that one. And then the highstruct.dat has two hydraulic structures with rating tables. So you can see here that we have an S means that's a new structure. Then you have the name of the structure. And then this is a channel to channel. So the first switch is 1. And you don't have to remember all this. It's easier to get it from the tables. And I'll show it to you in a second. This one means that it's a rating table. This is your inlet node grid element and your downstream outlet grid element. And this is the other control parameters that we didn't need for these structures. You'd need those for other structures. So if you watch the video that I made this morning, it'll be posted to the advanced lesson by the end of the day. If you watch the video, it'll explain how those structures work. And Creighton, if you just joined us, again, this documentation page is what we're following to work through Module 10. And now we've already done it over the past 2 weeks. And now we're just seeing what we put together. So the 3 videos will go together. Now, let's see. So then this is just stage time relationship, where this is a depth, sorry, it's not a stage time relationship, it's a depth discharge relationship where this is depth and this is discharge, and then this is 0 because we're not using this data. So this area table is just 0, and you don't even need this area table, but it doesn't hurt to have it. So it's okay to have it in there, but you don't need it. Okay, so 0.1 foot of discharge means 2 cubic feet per second through that structure. And again, last week we put those structures in for the 20th Street crossing and the 16th Street crossing, and we put those in as hydraulic structures. So you can see them here, and the video that I made this morning will be posted to the webpage and will show you and explain all of this information. I just wanted you to see it as a text file. Now we have the 3 files for the channels, and this is kind of what I really wanted to show you today. And we had a rectangular channel. Remember, this was all mixed geometry. A trap channel, you can see the T for trap, and a natural channel that has, each of these natural channels has an affiliated cross section. So let's start here with the rectangular channels. They are just, R means that's one cross section, one schematized cross section. This is the channel element number for the left bank, and that will coincide with the grid element number for the right bank. And these 2 files, chan.dat and chanbank.dat, will be written in order from upstream to downstream. This is your bank elevation on the left side, your bank elevation on the right side, and end value, width of the bottom width, depth, and this will be the length of the channel in that for that specific cross section. We'll look at that in just a second. Down here on the trap channel, we have all the exact same stuff. This is width, this is depth, this is length, and then 2 side slopes. Okay. And for the natural channel, what you get is the left bank element, the left bank node, the end value, the length of the channel, and then associated cross section number, which goes over here to the exec.dat file, and these are just station and elevation. So 0 from the 0, and then this is an 88.7 foot wide channel, and then that is your elevation data for the cross section. And then this, you can tell this one is an interpolated node because it doesn't have an X dash in front of it. So a cross section that is, a cross section that is X dash Greenway N1 will correspond to the cross section here. Let me get down to N1 right here. And if you hit the center button and select it again, you can see that this is the cross-section data. This cross-section data was cut off the map in the first lesson, in the first video, and applied to interpolated. Let me turn the cross sections back on real quick. Interpolated cross sections are from here to here. So that's how this specific natural type channels worked. And again, I'm sorry if this is kind of overly complicated because you wouldn't typically see this mixed geometry. Normally, I would just cut the cross-section data for these 3 channels, and I would just cut it straight as a natural channel. I wouldn't mess with the 3 different types of channels, but because I wanted to show you how to do it, video 1 shows you how to start setting it up. Video 2 shows you how to finish it off by adding the hydraulic structures and the inflow nodes. And video 3 is kind of an overview of what we did. So if you need to go back, go ahead and go back to video 1, and we'll show you again at the end of the video where to get all that. Okay, so that is just basically how these data files are work. Then once you get your data file set up, it's time to run the model, and you run the model and you get some outflow data as well. So the .dat files represent the data, and the .out files are created when the simulation is finished. So let's take a look at some of these ones that work well for channel revisions or channel. So let's see, we got this one here, Chan Max, CH volume, High Chan. These ones are good for channels. And then we also have the hydrostruct.out, because we do have a hydraulic structure. Summary.out we'll grab just to look at it. And let's go ahead with the vel times c.out, exec area.out. These are all kind of related to channels, all of these that I have listed here. And if you want to know something about these individual output files, all my output file data is listed in the Data Input Manual, Chapter 5. So it gives you a brief description of what's in each of these files. So what are we looking for when we're doing a quick review of our channel? You know, we want to see, is this channel working correctly? And if you've set up your data file correctly, like we showed you in the first couple of lessons, then you should be confident that everything is working okay. So what we're looking for when we scan through this data quickly is anomalies. So especially exec area.out, what do I not want to see? I don't want to see anything blow up in these numbers. Okay, so everything right here looks pretty good. Looks nice and clean on my cross sections. Now that's just like a standard cross section data. I'm going to go ahead and close this. And just so you know, this is sorted high from a low grid element to a high, so it's kind of backwards. So really what I'm looking for, don't want this blowing up. Actually, I think what's happening is that this is, oh, I see what's happening. This is only the natural channel. I gotcha. So that makes sense. Yeah, because it's cross-section area.out. It's only the natural channel. And then we have, let's just go through these quickly. This is your chmax.out. So all this is going to give you is for every channel, it's going to give you the maximum discharge, the time at which that occurred, and the maximum stage, and the time at which the maximum stage occurred. So again, what do I not want to see? I don't want to see 1,000 CFS in here, because I only have 400 CFS and 440 CFS in my hydrograph. So I don't want to see 1,000 CFS in this file. Also, I want this peak to be around the time where my peak discharge comes through. So if this said like 600, and the time was like 0.5 or something, then I would know that that's an instability. If the maximum stage and the maximum discharge timing are way off or don't make any sense, that might also represent an instability. And it'd be something that if you have an instability and you don't quite know how to fix it, Jim has made some really good videos on how to do channel stability and that's back on the regular website, flo2d.com. In the training packages has an advanced channel lesson that talks about optimizing and stabilizing channels. We'll let that come up in a minute. I don't know why that's taking so long, but we'll just wait for that. Okay, so that's your chanmax.out. It's just a really easy file to check. You're just looking for anomalies. CH volume is what I want to look for on CH volume is this guy over here. I don't want my CH volume to get above 0.001, because if it does, that means I have a volume conservation error with my channel, and I probably messed up some connection between two cross sections, or maybe I'm putting the water into the channel too quickly, or maybe I've messed up a confluence, or I have a drop structure that I didn't account for correctly, and it's causing a volume conservation because the water is being added to the system too quickly or taken away from the system too quickly, and it's causing instability and volume conservation issues. So we're done with these two. I'm trying to do the easy ones first. Here I have a inflow or a velocity for the channel. And you can see pretty much right away that the velocity is not bad. It's pretty good velocity for the channel. And so if you have something that you don't like you don't really think that this channel is capable of 8 feet per second, which in this case, I'd say I wouldn't want to see anything higher than like 10, maybe 15 feet per second in this channel because it's pretty flat channel. So if I saw something that I didn't want or didn't like, then I might think that there's an instability in this channel. But since my time of occurrence is right on the peak and it's not a massive change in velocity, I think that this one is probably okay. And one of the ways that I could confirm that is to review the hydrograph at that node, 17840. So let me show you how to do that. So if I wanted to check out that hydrograph, I'd use this program right here, Hydrog. This program comes from the FLO 2D Pro folder. I've got my Hydrog and Profiles program. You can also get MaxPlot, whatever, a few other programs, and you can copy those and pop them straight into, paste them right into the project folder. And then when you run it, you can plot the channel hydrographs. And in this case, I know the number I want to look at. It was, hang on, 17840. So I can just put that in there. 17840. Click OK. And you can see that I don't have any instability here. Nothing wrong with this. Indeed, my peak is happening right when my veil time C is reporting it. So I don't have any problems with that velocity. That's okay. Another thing that you can do to check velocity or to check and see if depth and velocity parameters are on target is you can compare your results to a open channel flow calculator. So let me see if I can grab one. I like to use the one at San Diego State. The open channel flow calculator from San Diego State is just really easy to use. Online calculations, normal depth prismatic channel. So you can put your discharge, bottom width, side slope, bottom slope, Mannings in here and hit calculate, and it would give you some values to compare to. So if your values are like way off from what you're getting in this open channel flow calculator, then you know you probably have some instability or something is wrong from what's flowing from upstream to downstream. And again, hopefully, yeah, if you go to the training packages and you're having problems with your channel, boy, everything is slow today. Let me let that training package, here we go. Come on. I was going to let this training package load to show you where you can go for help on making your channel run stable. Wow, that is slow. Well, we'll come back to it. It'll get there. Okay, so that's velocity. Then let's go summary.out again. So summary.out, what we're looking for right here is making sure that these values don't get above 0.001, and that if they do, then you have a volume conservation error. If this summary.out tells you your volume conservation error is either on the floodplain or the channel, the CH volume.out will let you know that your volume conservation error, if it's not in the channel, that'll be 0, and these numbers will still be higher than 0.001. Then you can see a little bit of information about your channel. What am I looking for here? I'm looking for numbers that don't make a lick of sense. Okay, so if these numbers in the channel storage and channel outflow are just completely ridiculously off, then you know probably something is wrong with your channel, and you need to maybe check your profiles or maybe check your area of the channel as it moves downstream, and we can show you that in just a second. So, and then again, just don't want to see any funny numbers here related to channels. Okay, so summary.out is pretty easy for when you're looking at it for channels. Vel time C is also pretty good. Let's see if our thing loaded up here. Yay. Oh my goodness. All right, channels. I'm just going to click it, but then I'll probably have to wait for it. So there, let's close that one. We'll wait for it. Let's come back here. Highstruct.dat. Highchan.out. Highchan.out. Yeah, these two kind of go together. So highchan.out is a pretty cool file. So it's going to give you all of this information: time, water surface elevation, depth. This is the depth of from the Thalweg, or the depth from the invert, velocity. And so Thalweg means like the bottom of the channel of, like, say, a natural channel, and kind of as that channel moves downstream. And then inverts that term is used more when you're talking about connecting a channel to a storm drain, or connecting a channel to a culvert. The invert of the channel is like that bottom elevation that you're going to connect to. Velocity, this is the velocity over time. Discharge, the calculated Froude number. Flow area, wetted perimeter, hydraulic radius, top width, width versus width to depth ratio, energy slope, bed shear stress, and surface area. So most of the time I don't really use these guys over here. So what I'm interested in is, do the numbers look accurate or normal or whatever? And if the numbers look okay, then I just ignore these guys over here. I don't want to see stars. I don't want to see negative numbers. I just want this thing to look normal. And then over here, the ones that I do use all the time are these guys here. Now, just these first like 6 rows of data. Sorry, that would be columns of data. And then these values here. So this is your maximum discharge and the time for this cell. And this is your maximum stage and time for this particular cross section. And these cross sections, just so you know, are based off of the grid element number. So if I had one that was looking a little weird and I wanted to review it in QGIS, I could just take this number right here. That's my channel right here, copy that number, bring it back into QGIS, and click the eyeball tool, and it'll zoom right to that cell. And then I can look at the cross-section data for that cell by using this info tool. And I can click on that cell, and it'll give me information about the cross-section. And then I can go upstream and downstream. Or I can do the same thing, except I can do it in the channel files, the .dat files. But if you do it here, you can fix things. If you do it in the .dat files, you're going to have to come here to fix things anyway, so you may as well, do your revisions or your review from here. Okay, now important things about this file. What do I not want to see? I don't want to see this number right here being extremely different from this discharge number right here at 11 hours. I don't want to see that being extremely different. What else? This number, maximum stage, again, I want to make sure that that maximum stage matches this down here. And I don't want to see any, again, I don't want to see any stars. Stars mean the data got too big for the model. I don't want to see things blowing up in here, and I don't want to see massive instability or surging. So this is not the best file to review for problems with stability. That would be a Hydrog. And again, if you opened Hydrog and you can plot your channels, and you can just kind of go through these individually. And what I'm looking for, I don't want to see any weird spikes. And I'm just going to check each channel element and just make sure that nothing starts bugging out or becoming unstable. And I've already done this, so I'm not going to waste your time with it, but I'll just let you know that it's pretty easy to kind of work your way through the list. And you can change your You can change your nodes very easily, move downstream and check all of those. And if they all look clean and good, then your model's good. If they have instability, they might get real spiky, and that means you need to, again, go back to Jim's video that we still haven't been able to load. Let's see if it finally loaded. And go in advanced lectures. You can see that it has channel optimization presentation. And if you click the download button, it'll take you right to, oh, it is just FLO2D website that's slow. It'll take you right to here, and then you can watch the video, and it'll teach you how advanced channel theory and how to fix things. Okay, so we're good there, and we're good here for now. Okay, last thing. Now, if you have a hydraulic structure, this will be the discharge at the inlet, and this will be the discharge at the outlet. So if I get down here where we actually have some discharge, this number is positive and this number is negative because the flow is moving through the hydraulic structure from upstream to downstream. If this changes and this becomes negative, this becomes positive, that means the flow is moving in the opposite direction through the structure. So if the number are positive, negative from upstream to downstream, that means that the flow is moving in the direction of flow, in the actual normal direction of flow. If the negative and positive signs change columns, that means the flow will be moving upstream because you allowed for the tailwater condition to allow the flow to move upstream. That's the way that this hydrostruct.dat file works. What do you not want to see? You don't want to see, well, this should pretty closely match what's happening in the hydchan.out at the location of this structure. So check this out. If I come back up here to my structure and I grab my inflow node, I'm going to copy my inflow node. I'm going to Control F to find it, and I'll paste it in here. And then I'll put a space behind it and click Find Next. All right, hang on a sec. I'm going to take that space and put another space in. There we go. So you can see here that this is my inflow at that structure. So if this value, or even like if you go upstream a couple of cells, if these values start changing significantly, obviously a hydraulic structure is probably going to reduce the flow of the water coming down the channel because it's going to constrict it. Sometimes it doesn't constrict it. Sometimes the hydraulic structure is a nice big box culvert and the channel is a ditch, a dirt ditch. So sometimes it doesn't really restrict the flow. But in this case, we should probably see a bit of flow restriction through the structure. And you should be able to determine that flow restriction by reviewing the two data sources, hydchan.dat, hydrostruct.out. What you don't want to see is like a major drawdown of flow right here in the water surface profile. And maybe I don't want to see a fluctuation in discharge. It's okay to see like a backwater, but may not. That's kind of what you're looking for with hydraulic structures. And obviously you don't want to see anything ridiculous like extreme water surface elevation change. Doesn't make any sense. Now let's take a quick look at, let's see, what was I gonna show? I wanted to show, oh, I know what it was. Okay, sorry, let's go back here real quick to the hydchan.out. Now what I'm gonna do is go to the very last structure. Now, the very last structure, because it's an outflow node, and I'm sorry, I meant the very last cross section, doesn't really have any data, but I want to plot it in QGIS. So what I did was let me just page up here. Maybe a page up would work a little faster. So what I did was because I wanted to plot this in QGIS. So I just copied this data from this line right here, and then I actually just pasted this data right here because this data was just 0, 0, 0, 0. And then I saved it. Now, if I go back to QGIS, I can actually import that data into the map using this button. So this is new. Sometimes if you guys are not quite paying attention but you do channel modeling, pay attention here because this is new. So I hit this button and then I go to the export folder and I grab that HiChan.out and click open. And then I can use, okay, you know what? I might have messed something up here because my plot wasn't on there correctly. So let me open my plot back up. Okay, here's my plot panel. So now when oh man, I wish I could dock that in here, but apparently I'm not going to be able to dock it, but it should reset itself when we close. And if I use this guy, nope, sorry, this guy, this is the profile, channel profile. If I click that and then I click here, I can choose that left bank and it'll show me my profile. And this is, let me see if I can make it look a little nicer. This is the profile, the bed profile. So you can see that it's clearly not right. There's something down here bugged out. So I could fix that. And you can see the yellow is the maximum water surface elevation, which doesn't make any sense that that's yellow. It probably should change that color to blue. But anyway, for now, that is the water surface elevation in this one. Now, if you go to another one, now in this, if you use this tool, you have to have the water surface elevations. And if I were to go, so you can see that this one looks more realistic. And you can see here that that structure is indeed drawing that water surface elevation down. But in that structure might actually do that because it's a huge structure and there is a bit of a drop on the downstream side of it. So it might actually draw that water surface down from this point right here. That might be okay. And since I didn't have any other issues with my channel, you know, it looked really smooth and I didn't have any instabilities, I think I would trust it. We'll get this last one. Now look here. See, this looks pretty good. So it gets real steep after it leaves this system, like after right here, it gets real steep down to this point. And so you can see that that's exactly what's happening. And then it's a little less deep because the water's moving a bit faster. And you can see that there's a bit of an issue right here, again, with our hydraulic structure. So we might have to check the cross section right there, but it looks okay. For the most part, it looks fine. Now okay, so that's how you can look at your channel profile, but let me show you why I made that change. So down here in the very last cross section, I changed these. They were 0. And I want to show you what happens. I want to show you why I changed them. Now, don't worry about this. JJ and I will fix this, but for now, it's kind of a pain in the neck because if I were to import this data again, it keeps taking me to the wrong place, and then re-click on this guy, you'll see that it doesn't like 0 data. So what we're going to do with it is we're going to, if the value is 0 or null, we're going to set it to the bed elevation of the channel. So that's why I replaced that number right there, because that outflow node doesn't get discharge. The outflow node gets discharged, not the cross section. Let's put it that way. Okay, so that's pretty much it for reviewing your channel. Let's see if anyone has any questions about any channel modeling they're doing. Go ahead and plug those questions into the answer thing, or question thing. And those of you who just got, or this is your first webinar, welcome. First of all, welcome to FLO 2D. Thank you for attending. And let me see, what I wanted to show you was this dude right here. No, not that. Wrong one. This guy right here. So what we've been working on over the past 3 sessions, we do a weekly webinar every Wednesday. What we've been working on over the past 3 sessions is this module 10. So you can see that the module, the part 1 video is complete. and added. The step-by-step instructions are good. The step 10, the new video is complete. I just need to upload it to YouTube and connect it here. And then today's video will go after the summary to show you how to review the channel. That'll be uploaded today as well. And then for those of you, again, if you just started, documentation.flo-2d.com, and follow the setup instructions, and then you can work through lesson 1 through 6 to get yourself comfortable with FLO 2D and QGIS. Okay, I'll stop the recording here, and then we'll go over questions.